Okay, this is academic environment. Here I will be teaching you the lesson on trigonometry. The question says right now, simplify the following without using a calculator. So I'm going to solve this problem. I'm going to change cos 56 degrees, which will be cos into 90 degrees minus 34 degrees, then cos 26 plus, and I'm gonna change cos 146, which is cos, into 180 degrees minus 34 degrees sine of negative 26 degrees. Then cos into 90 degrees minus 34 is in a first quadrant. Therefore, the answer should be positive, which is sine 34 degrees. Cos of 26 degrees plus. Then cos into 180 degrees minus 34 degrees. That is a second quadrant, which is, okay, we all know that here we have 90 degrees minus theta. Here we have 180 degrees plus theta, 180 degrees minus theta, and 90 degrees plus theta. Here we have 180 degrees plus theta and 270 degrees minus theta. And here we have 360 degrees minus theta and 270 degrees plus theta. Therefore, here cos into 180 degrees minus 34 is in a second quadrant, since here we have 180 degrees minus theta. Therefore, cos is negative in a second quadrant. Therefore, that's negative cos 34 degrees sine into negative 26 degrees. Therefore, we have sine 34 degrees cos 26 degrees plus, then negative cos 34 degrees times into sine into negative 26 degrees. Therefore, you have to know these rules, that cos into negative theta is equals to positive cos theta, and you have to know that sine into negative theta is equals to negative sine theta, and tan into negative theta is equals to negative tan theta. Therefore, here we have positive cos 34 degrees, then sine is negative, therefore the sign will change to, and we have sine 26 degrees. Oh, I'm missing something here. Negative times negative should be positive, then cos 34 and sine 26 degrees. Therefore, this is a compound angle. Since we have sine 34 degrees cos 26 degrees and cos 24 degrees sine 26 degrees, this is a compound angle of sine, which is sine into a plus b, and this is sine a cos b plus cos a sine b. Therefore, here in this case we have sine into 34 degrees plus 26 degrees, which is equals to sine 60 degrees, and I think that's root 3 over 2. Let me confirm. Sine 60, yeah, that's root 3 over 2. That's all for this problem. Thank you. Okay, this is the second problem, which is 2.2, under this title, which is simplify the following without using a calculator. Therefore, to solve this problem, I'm gonna solve this tan into 180 degrees plus x. 180 degrees plus x is in the third quadrant, which is this quadrant. Therefore, tan is positive in this quadrant. Since we have tan here, we have sine here, we have cos here, and then we have all. Then you can read follow like all of them here in this first quadrant are positive. It's like all students take coffee. Therefore, since tan is in a third quadrant, therefore it is positive. Then we have tan x. Then 360 degrees minus x is in a fourth quadrant. Therefore, we have positive cos x. Positive cos x all over. Then sine into x minus 180 degrees is like negative. Let's take out this negative, and we have sine into 180 degrees minus x. Negative times negative will be positive x, then negative times this positive here will be negative 180 degrees. Therefore, we have negative into sine into 180 degrees minus x is in a second quadrant. Therefore, we have sine x times this negative will give us negative sine x. Therefore, we have negative sine x. Therefore, cos into 90 degrees plus x, we know that 90 degrees plus x is in a second quadrant. 90 degrees plus x is in a second quadrant. Therefore, cos is negative here, but we know that cos must change to be negative sine x plus. Then we know that 720 degrees will be 360 degrees plus 360 degrees. It's like you moving from 0 to here, which we all know that cos into cos 360 plus you will be in a first quadrant. Therefore, cos must be positive. When you move twice the rotation of 360 degrees, cos will be positive. Therefore, you have cos x again. Then we know that cos into negative sine x, here are the rules. Cos into negative theta will be cos theta. Therefore, you will have cos x again. Therefore, tan x cos x all over. Negative times negative will be positive. Sin x times sin x is sine squared x. Plus cos x times cos x will be cos squared x. Therefore, what you need to know is that there is a rule which says sine squared x plus cos squared x must always be equals to 1. Therefore, you know that cos squared x is equals to 1 minus sine squared x, and sine squared x must be equals to 1 minus cos squared x. You all know that tan x must be equals to sine x all over cos x. Here we have sine x, we have tan x. Therefore, tan x must be equals to sine x all over cos x times this cos x all over. We know that this is always equals to 1. Therefore, cos x must cancel cos x, and then we have the answer which is equals to. Okay guys, here is another problem which says prove the identity, which is cos 2x plus cos squared x plus 3 sin squared x all over 2 minus 2 sin squared x, which is equals to 1 over cos squared x. Guys, we all know that mathematics is about the rules. Here are the rules. Sine sine squared x plus cos squared x is always equals to 1, and we know that sine squared x will be equals to 1 minus cos squared x, and cos squared x will be 1 minus sine squared x, and here we have cos 2x must change cos 2x. We know that cos 2x will be equals to cos squared x minus sine squared x, and cos 2x must also equals to 2 cos squared x minus 1, and must also equals to 1 minus 2 sine squared x. So to solve this problem, which is left hand side, cos 2x plus cos squared x plus 3 sine squared x all over 2 minus 2 sine squared x. We prove that this left hand side is equals to right hand side, which is equals to 1 over cos squared x. Therefore cos 2x, we know that when you look at this problem, you see that we have cos squared x and sine squared x. So let's change this cos 2x to be cos squared x minus sine squared x. Cos squared x minus sine squared x plus cos squared x plus 3 sine squared x all over. Let's take the common factor. Here we have 2, then 2 into 1 minus sine squared x. Therefore we have cos squared x minus sine squared x plus cos squared x plus 3 sine squared x. 2 into 1 minus sine squared x. Oh, let me change this one. This will be, as you see here, 1 minus sine squared x is equals to cos squared x. Let me replace this part here. It will be equals to cos squared x, and here cos squared x minus sine squared x is equals to cos 2x. So let me continue. Cos squared x plus cos squared x will be equals to 2 cos squared x, and minus sine squared x plus 3 sine squared x will be equals to positive 2 sine squared x all over 2 cos squared x. Again, we have a common factor here, which is 2. Let's take out this common factor. 2 into cos squared x plus sine squared x all over 2 into cos squared x. This is pretty simple, guys. Therefore 2 divided by 2, it's gonna cancel. Therefore cos squared x plus sine squared x, here is the rule that sine squared x plus cos squared x must always be equals to 1. Therefore we have 1 all over cos squared x, which is equals to right hand side here. Therefore we've already proved this problem, which is equals to right hand side. Thank you.